In this supplement, we will describe a theorem associated with existence and uniqueness of solutions to second-order differential equations, linear second-order differential equations. So let's begin by considering the initial value problem, which is for linear second-order differential equation as described here. Differential equation involves these functions, arbitrary functions p, q, and g, multiplying the first derivative, the f value y, and the right-hand side forcing. And we are given this initial condition y equals y0 and y prime at t equal to t0 is equal to y0 prime. So for this differential equation, under these conditions where the functions p, q, and g are continuous over an open interval I, this is the definition of some open interval between limits alpha and beta for t. If we have such a problem given to us, then the theorem says that there exists exactly one solution to this initial value problem. We can represent this solution as y equals phi of t. It is very useful and important to know that there exists exactly one solution to this problem, so we can proceed and confidently solve the problem and we won't run into any problem. So it's a very useful property that such a solution exists, and of course the theorem also asserts that this can be found throughout this open interval I, for which these properties for the functions p, q, and g in the differential equation were satisfied. All right, so we can interpret this result. We can say that solution exists and is unique and is twice differentiable over this interval, and moreover the solution exists for arbitrary values of these constants y0 and y0 prime, which go in defining the initial value problem, and so we can vary these and obtain solutions as a function of these initial conditions and so on. It's a very nice property to have, very useful. Of course, at the end we should note that such a general result does not exist for nonlinear second-order differential equations. There, over some limited conditions, one may have solutions.